Hello, everyone. Thank you so much for your time today. My name is Urvashi Chaudhary, and I'm a Principal Product Manager on Amazon SageMaker. I'm really excited to introduce Amazon SageMaker pipelines to you today. Let's look at our agenda real quick. We'll start with discussing the challenges in building machine learning workflows. Then we'll look at the overview of Amazon SageMaker pipelines, and we'll wrap it up with a quick demo. Machine learning is a very iterative and collaborative process. There are teams of data scientists and ML engineers working with DevOps and machine learning engineers, trying to put models together to solve business problems. There's a lot of iteration and experimentation that goes in building the model itself through steps like feature engineering and model building and training. And once the models are built and trained, you have to manage the models in production and make sure that they are scaling and running as a production service. This process is not linear. There's a lot of iteration involved, and you have to retrain your models and keep them updated so your models are always accurate and representative of the new data. So let's look at some of the challenges in building and scaling machine learning workflows. The first challenge that data scientists typically encounter is in building the machine learning workflow itself. Workflows can become quite complicated as your pipelines can have many steps involving data processing and training and hyperparameter tuning. Each of these steps can also have a lot of dependencies between them, which makes it hard to troubleshoot workflows once you've created them. You not only need to keep track of the data artifacts, but also the model artifacts. And this increases reliance on engineering teams. As you iterate and scale and build your machine learning models, the next challenge is typically in managing these models. It's hard to keep a track of the model versions and understand which models are in production, which endpoints are running, when the models were trained, and how you got to those models. Finally, it's difficult to automate and scale this process. With software engineering, there are tools such as CI/CD that have automated this process. Applying the CI/CD tools to machine learning directly is challenging because you're not only managing code, but also managing data and model artifacts. And as you scale your machine learning pipelines and have several iterations, you also are challenged in tracking the end-to-end lineage. And a lot of times you need to build custom tooling to keep track of all the different artifacts throughout your machine learning workflows. I'm really excited to introduce Amazon SageMaker Pipelines, the purpose-built CI/CD service for machine learning. Amazon SageMaker Pipelines helps you build, automate, manage, and scale machine learning workflows using SageMaker Studio. Let's see how Amazon SageMaker Pipelines makes it easy for teams to collaborate and accelerate machine learning projects with CI/CD. First, Amazon SageMaker Pipelines makes it easy to build machine learning workflows by providing a Python SDK so you can quickly construct your machine learning pipelines. As your pipelines are running and your models are being built, you can easily troubleshoot these pipelines by viewing their executions in real time in SageMaker Studio. The Amazon SageMaker Model Registry helps you catalog and manage model versions. So even as the number of models scale, you don't have to build custom tooling to manage these versions. To scale machine learning ops, Amazon SageMaker Pipelines provides built-in support for CI/CD through published templates, and you can also bring your own custom MLOps templates to enable CI/CD. When you use SageMaker Pipelines, you get built-in lineage tracking capabilities, so you don't need to build any additional tooling. Let's see how Amazon SageMaker pipeline works. You start with your input data and construct a model building pipeline which generates a model. You validate that model and then register it to the model registry, depending on whether the model meets your conditions and criteria. From the model registry, you can deploy models into production either for real-time inference or for batch scoring. As you get triggers on model drift or new data changes or code changes, you can automate the entire process of building machine learning models as well as deploying them into production. Let's look at the specific capabilities of Amazon SageMaker pipelines. To build machine learning workflows, you can use the Python SDK and define a set of parameters, steps, and the data dependencies to construct your pipeline itself. When building a model building pipeline, you can orchestrate different SageMaker jobs, such as data wrangler and processing for processing data, SageMaker training for training your machine learning models with different hyperparameters, batch transform for scoring models on batches of data, and model registration steps to register models into the model registry. You can even automate your deployments and executions of these pipelines through the CI/CD capability or run executions manually through Studio and notebooks. As your pipelines execute in real time, you can see the visualization of the pipeline in SageMaker Studio. You can look at the details of every single step of your pipeline and get the related metrics, see the different artifacts and parameters for those executions, as well as logs from Amazon CloudWatch. You can also troubleshoot your pipelines easier by caching certain steps of the pipeline. We'll look at the details in our demo, but here's a quick screenshot showing you the different executions of a pipeline in SageMaker Studio, as well as the view of a real-time execution of the pipeline with details of a particular step, as well as the logs for those steps. So now that we have our model building pipeline, which is running a DAG and creating models, you can register models into the model registry. The model registry is a catalog for models and versions. When you register models, SageMaker automatically versions them. And you can also associate metadata as well as metrics with your models when you register them to the registry. This helps you compare models and look at the details of the models once these have been registered. The model registry also provides a built-in approval workflow, so you can approve models from Amazon SageMaker Studio and decide if those models are meant to be promoted to production or not. You can even register models with approved status automatically as part of your model building pipeline. Many times when customers deploy models in production, they follow the AWS best practices of deploying them in different AWS accounts. You may be setting a pre-production environment in one account and a production environment in a different account. And in order to ease the transition from different accounts, the model registry supports cross-account access of model versions. This makes sure that you don't need to copy the model artifacts from one account to another or have to rerun the same pipeline as you try to move your models from one stage to the other. We'll look at more details in the demo, but here's a quick screenshot that shows you the model registry view in SageMaker Studio, along with the different versions, as well as the approval workflow. And as models get deployed in different stages, you can see the updates in the model registry for that particular version as well. In order to automate and scale ML ops, Amazon SageMaker Pipelines has a new concept of SageMaker projects. You can create a project in SageMaker Studio and use a built-in MLOps template that sets up the entire CI/CD infrastructure for you. This includes a code repository with the starter code, as well as the code pipelines, code commit repositories, and the code build stages. Amazon SageMaker provides built-in MLOps templates for model building, model deployment, as well as end-to-end model building and deployment. If you would like to use custom CI/CD templates, you can also use the SageMaker built-in templates and extend them, or you can write your own custom CI/CD templates using AWS CloudFormation and publish them in Service Catalog. As I mentioned before, Amazon SageMaker Pipeline uses AWS code services to deliver the continuous integration and continuous delivery capabilities. Here we have a screenshot of an Amazon SageMaker project that has been created in Studio. The projects also group your related SageMaker resources, so you can see the different machine learning activities like model building pipelines, model registry entries, and endpoints along with it. In order to scale machine learning ops, the built-in CI/CD capabilities for Amazon SageMaker pipelines can be used to get started quickly. But if you want to customize the CI/CD steps or the different accounts that the models are deployed in, or if you need to customize the different testing stages or the specific stages that your models need to be running through, you can build your own custom templates and publish them in AWS Service Catalog. You can also automate the execution of your CI/CD pipelines by triggering it based on code changes in the code repository or based on data changes. So when new data arrives in S3, or you could even schedule these changes based on scheduled events. When you use SageMaker pipelines, you get built-in end-to-end lineage tracking for your model artifacts as well as data artifacts used in your end-to-end ML process. You can easily see the lineage details from SageMaker Studio for each and every step, or you can even query using the SageMaker Python SDK. Lastly, if you want to track lineage for custom entities, you can use the SageMaker SDK for the same. Here we have a screenshot showing the lineage for a model building pipeline and also for a model deployment where we can see the different model versions and the pipelines that were used to generate this model. Let's look at a quick demo.
To get started with SageMaker pipelines, the first thing we need to do is make sure that our Studio domain has the option for projects enabled. If you are creating a new domain or adding new users, you can do this as part of your create flow. Or if you have an existing domain, like I do, you can simply edit the settings to turn on this option. This task will be typically done by the Studio administrator. Now that my Studio administrator has enabled projects for me, let's go to SageMaker Studio, which is our IDE for machine learning. Here we go to the navigation and we see the new SageMaker capabilities. To get started with SageMaker pipelines and have built-in support for CI/CD for your machine learning workflows, we start by creating a project. A project is a grouping of SageMaker resources and activities centered around a machine learning problem. For example, if you're working on an ad ranking problem or a churn prediction problem, you may create a project for each. When we create a project, we see that we have options to pick different MLOps templates. These MLOps templates set up the CI/CD infrastructure for your project, including code commit repositories, code build stages, and code pipelines for the continuous delivery. SageMaker has 3 built-in templates, one for model building, one for model deployment, and third, for end-to-end model building and deployment. If your organization requires a custom CI/CD pipeline or tooling or processes, you can also create your own CI/CD pipelines using CloudFormation, publish them in AWS Service Catalog, and once published, it will be available to your studio users through the organization templates option. Here, for our project, we will just pick the model building, training, and deployment template and get started. So I give my project a name and some description, and I can optionally add tags as well. SageMaker automatically tags each project with the project name and a unique ID, and those tags are also propagated downstream to the SageMaker resources and AWS resources that get created as part of this project execution. This will take a few seconds to set up. In the meantime, let's go look at a project that I've already created. Here we see the different SageMaker resources that get grouped together, including repositories. These are repositories that SageMaker creates on your behalf that you can clone locally and work on your project. The model building pipelines that get generated. If you have experiments, you can create your experiments here and have them listed. The model groups represent the model registry entries for this project. And the endpoints are the real-time inference endpoints associated with this project. Let's dive into each of these details. For us to get started on a project with the right version control for our code definitions, and in order to collaborate with our team, we'll use code repositories. Here, I've already cloned the repositories locally, but if I were creating a new project, I would be able to clone them by clicking a clone option that we can see in a different project here. Once cloned, we can simply select the local path here and explore the repository. We start with the README, which gives us an overview of the structure of this repository, and it also explains that there is a sample code here for the Avalon dataset where we will predict the age of the shellfish using its physical characteristics. So let's jump into the model building pipeline where we'll define our model building workflow. We go to the pipeline.py file where we will use the SageMaker SDK to define the pipeline. The first thing we set up as part of defining our model building pipeline are parameters for execution. Here we have instance types as well as the status with which we register the model to the registry as our parameters. Next, we define the different steps that will get executed in our pipeline. First, we define a pre-processing step where we use a pre-processing file, which is the preprocess.py file here that we see, as an input to the SageMaker processor, which uses scikit-learn. Once we've defined this processing step, we use the output of the processing step as an input to the next training step. Here we define our hyperparameters for training, and we use SageMaker's XGBoost algorithm to train this model. Once the model is trained, we use SageMaker processor and use a custom evaluation script, which is defined in evaluate.py file here. And we define our evaluation step. Next, we define our model registration step, where we register the trained model artifacts into the model registry. However, we don't want to register every single iteration, so we define a conditional step where we evaluate the model metric, in this square, the MSE, and we ensure that we only register when it is below a certain threshold. Finally, we define our pipeline, and we are set. So the first time you create the project, this pipeline automatically executes But if you're using a project and you want to change parts of your pipeline, like the parameters that you've defined or the steps or the code, you can simply make changes to your Python file here. So I'm going to change the instance types. I save my changes, and I use SageMaker Studio's Git plugin, and I stage my file change. And I commit this code, and I push it to the main repo. Once this is complete, this will trigger the model building CI/CD process, which will create a new pipeline execution for us. Let's go back to the project and see our pipeline executions. So here I have several pipeline executions that I've already created and run in the past. Let's look at the graphical view of the pipeline that we just built. Here we see that we started with the pre-processing step, followed by training, evaluation, the conditional execution, following which we register the model to the registry. We can also see the parameters that were used for this pipeline. You can even kick off executions of the pipeline using SageMaker Studio by just changing the parameter values here. In our case, since we had just created the pipeline execution using our Git repository, we'll wait a few seconds for the build process to finish, after which we should see a new pipeline execution here. Let's double-click into one of these executions and see the capabilities that SageMaker provides. First, we can see a visual representation and a status of each of the following steps. Here we see that the pipeline has successfully executed, so all the steps are green. We can step into each and every step of the pipeline and look at the related artifacts like the input data sources, the related logs for that step, as well as lineage information and the parameters. So here we're looking at the processing step. We can also look at the training step where we can see the training metrics as well as the training logs. When we look at the evaluation step, we see that the evaluation was true, which is why our pipeline was registered. We can also see the different pipeline parameters that were used for this execution. And if needed, we can also download our pipeline definition file here. So let's go back and refresh our screen here, and we can see that the code changes that we had made for the instance type have triggered the CI/CD for model build, and we have a new pipeline execution. So if you are a team of data scientists collaborating, your individual code changes will trigger new pipeline executions that you can see here. So as the pipeline finishes, the last step is to register the model to the registry, from where we can automate the model deployment process itself. So let's go to the model groups, which is the model registry entry for this project. And we can see the different versions of the model that were registered to the model registry. You can see who modified them. You can see the status of each model version. And you can see the stage that the models are in. SageMaker automatically versions new models as they are registered to the registry. So here we see for one of these models that it is in prod stage, and the other one, which is approved, is in a staging state. So the CI/CD template that we have requires models to be approved in the model registry, either manually through the data scientist approval in Studio, or automatically as part of the registration process. Once the model is approved, the CI/CD pipeline deploys to a staging endpoint and a prod endpoint. We can also see the metrics that were associated with the model when it was registered and when it was evaluated. Similar to pipeline executions, we can also look at a model version and see the specific details of the pipeline and the execution that resulted in this model creation. So we can quickly look at the execution, and we can go back and look at the training step that resulted in this model version. This is great for lineage tracking and being able to organize and have details about your models at all times. So here we can use the approval workflow to update models as well. So I can just either approve this model, in which case the CI/CD template that we've selected will first deploy it to a staging endpoint, and the continuous delivery process waits for the DevOps team to approve the model before it can get to the production stage. We'll look at that shortly as well. So here we see that our model has been approved. Now let's put on our DevOps hat and see what's happening in the CI/CD for model deployment. So here we see that we have our code pipeline, which is doing the continuous integration and delivery for our model deployment stage. Here we can see that we have a model deployed in staging, and before it can be promoted to production, it's requiring a manual approval. So let's go ahead and give approval to this model because we can evaluate whether our staging tests have passed or not. And now we can see that once this model approval is provided, the model will then get promoted to production. And here we can see that we have a new production endpoint deployment and update in progress. Let's go back to our project and look at our endpoints. Let me refresh it quickly. You can see that our staging endpoint is getting updated because we approved a new version of the model, which was model 5 just now, to get into the staging state. Similarly, the model version number 4, which was in staging, we used our code pipeline to update that model from staging to production stage. So here, after a couple of minutes, both of these model versions would be in the new stages.
That brings me to the end of my demo. Here, for simplicity, the built-in templates deploy models to staging and production endpoints in the same AWS account. However, if you need to deploy your models in different accounts or customize your CI/CD process to have different stages or have different tools that you use, you can create a custom template and use that for creating the projects. So we had a look today and we learned how Amazon SageMaker Pipelines makes it easy to build, manage, automate, and scale end-to-end machine learning workflows. Amazon SageMaker Pipelines is generally available in all the AWS commercial regions where Amazon SageMaker is available. The ML Ops capabilities are available in all regions where AWS Code Pipeline is available. You can use Amazon SageMaker Pipelines through Amazon SageMaker Studio or the SDK, as well as through the CLI and APIs. Lastly, you only pay for what you use. There's no additional cost to building and creating pipelines. You only pay for the SageMaker resources that you use and the AWS CI/CD services that you use when you're using Amazon SageMaker Pipelines. Well, I hope you enjoyed this session today. I'm really excited to see how you use Amazon SageMaker Pipelines to build, manage, automate, and scale your end-to-end machine learning workflows. Thank you.